Hello and welcome back. In this video of concept 14, we discuss about conditions for static equilibrium of a rigid body. We have seen earlier that forces can be reduced into equivalent force couple moment system. For example, consider a beam acted by two forces, and we can replace this force system with an equivalent force couple moment as indicated. Instead of two forces, 80 Newton and 100 Newton, we have only one force which is acting at point A, which is the vector sum of the two forces. And if you identify a couple moment MA, which is equivalent to the moment of forces 80 Newton and 100 Newton about A, then we can find that couple moment MA at the location A. So together, a single force and a couple moment, which is equivalent to this system is equivalent to the force system uh, we started with, which is 80 Newton and 100 Newton acting at point B and C of the beam. Now, let us consider a rigid body which is acted by multiple forces and couple moments. For example, the rigid body is acted by F1, F2, and F3, three forces, and it has couple moments M1 and M2. Now we can reduce this force to a single force couple moment system, an equivalent force couple system as indicated, using the procedure we just adopted. Now the necessary and sufficient condition for a rigid body to be in equilibrium is that the resultant force acting on it is zero, and the sum of moments of all the forces about any arbitrary point inside or outside the body should be zero. That is, net resultant force R should be zero, and net moment of all the forces about any arbitrary point will be zero. So this is called condition for static equilibrium for a rigid body. And that means if it is not in equilibrium, the rigid body will either translate, that is move, or it can rotate about some arbitrary point. Now we need to do some typical problems for this session, and before that we need to understand certain support reactions. So the case A is a roller support. So you can see that a beam is resting on two rollers, A and B. So rollers can provide reaction forces at the point of contact, but this reaction force will be always perpendicular to the support plane. So that means the reactions at A and B, which is RA and RB, will be always perpendicular. And also note that roller support cannot create any or provide any reactive moments. That means if you are applying a force which is not vertical, some inclined force, that means the system will not be in equilibrium. It will just keep rolling. So that's why we say that a roller support cannot provide reactive moment at the support. The second category of support is called a pin joint support. A pin joint support can provide reactive forces which may be perpendicular or which may not be perpendicular to it, depending on the external forces applied to the beam. And in this case also, this kind of support, pin joint support, cannot provide any reactive moments at the support, because if you make an inclined force, it will rotate, freely rotate. The pins means it can freely rotate about that pin. So that is the second kind of. Now the third kind of support is a fixed support. Fixed support means you have a beam which is fixed at one of the end. So the characteristics of such support is that it can provide a reactive force which may or may not be perpendicular depending on the external force acting on the beam. Plus, it can also provide a reactive moment at the support. depending on the forces we are applying to the beam. So it's a possibility of having an inclined reaction force Ra at A, and also a possibility of a reactive moment M at A. Now, this background, let us quickly go through a problem of rigid body equilibrium, which is shown in the figure. We have a beam of 100 kilogram, and it is 6 meter in length, is acted by a force of 100 Newton at point B, which is 1 meter from the point A. The question is, draw the free body diagram of this beam and find the support reactions at the fixed end and the reactive moment at support A. So in order to solve this problem, the first step is to find the free body diagram. Now, how do you do the free body diagram? So essentially, you draw the beam and show all the forces acting on it. So already it is two forces, 100 Newton, and the weight of the beam, which is 100 times 9.8, is shown in the figure. And since it is in equilibrium, we know that there is a reaction at A, which is Ra, which can be inclined or perpendicular. We don't know this reaction force. And since it is a beam fixed at one end, we know that there will be a reactive moment at A in order to keep the whole system in equilibrium. Now let us solve for the MA and RA. So the two equations we have is R equal to 0, sum of all the forces equal to 0, and sum of moments of all the forces equal to 0. So this is the necessary and sufficient condition for a rigid body in equilibrium. So what is R? So sum of all forces of this beam. So we know that there is 1200 Newton acting in the minus J direction and 980 Newton acting in the minus J direction, plus Ra, which is the unknown. So sum of all these forces will be 0. We can solve for Ra straight away from this equation as Ra equals 2180 Newton in the positive J direction. Now we have forces acting at B and C. We need to find the moment of these forces about A. So in order to do that, let us write the position vector of point B, which is RB, which is 2I, and then RC is 3I. So we know that the sum of all the moment of forces on the body should be 0. So we have RB cross 1200J in the minus direction plus RC cross minus 980J, which are the moments of forces about A, plus the reactive force acting at MA. So the sum of all this should be 0. So we know how to do the cross product of RB and 1200 Newton acting in the minus J direction. So we can solve the MA as 5340 in the K direction. So remember, the unknowns Ra and Ma can be solved in this problem straight away from the two equations, which comes from the necessary and sufficient condition for a rigid body in equilibrium. Consider another problem. A beam of 100 kilogram is resting on two roller support, which is acted by a force of 1200 Newton as indicated in the figure D. And we need to draw the free body diagram of the beam and find the support reactions at A and B. The first step is to draw the free body diagram. So free body diagram means you're showing all the forces, external forces and reactive forces on the beam. So external forces are already shown, 1200 Newton and 980 Newton acting at C. So we also show the reactive forces at A and B, so that this will be the free body diagram of the beam. Now the equation we're going to use is R equal to 0, sum of all the forces equal to 0, and sum of moments of all the forces about any point A, any arbitrary point, here we choose it as A, equal to 0. So this is the condition for static equilibrium of a rigid body. So what is R equal to 0? So we know that 1200 Newton is acting in the minus j direction, 980 Newton is acting in the minus j direction. And since it is a roller, we know that RA and RB is acting in the positive j direction. So still both of them are unknowns. So there are two unknowns in this equation. So we need another equation to find out one of the unknowns. So in order to do that, we use the second equation, moment of all forces about point A equal to 0. So we have RD is 2, RD is 1I cross 1200 Newton, which is acting at D, plus RC. RC is in this case, because it is at the center, it must be 2I. Okay, so I didn't show that in this equation, but remember that RC, which is acting at the center of the beam, the weight is acting at the center of the beam, therefore RC should be 2I cross 980J plus RB cross the capital RB, which is the reaction at B. Now let RB is the magnitude of the reaction at B, and the position vector of RB, small rb equals 4I. So we can write the RB cross capital RB as we expand the determinant, we will get it as 4RB. So if you just expand that equation, you get 4RB. So that we are substituting here, RB cross RB, we substitute from this right hand side explanation or description of that step. We substitute 4RB here, and we do the cross product of RD and 1200 and RC and 980. We get 1200 because this is 1. So R is 1I. We get minus 1200 plus 980 times 2K plus 4RB equal to 0, from which we can solve for RB. RB is 1200, 2180 divided by 4, answer 4 is 545. And since RB is 545, we know that is RB is 500. The vector RB is 545 in the J direction. So you plug this back into 1, you get RA as 1635J. So this is a simple problem of beams involving two rollers. Essentially, we use two equations, the condition for static equilibrium, the sum of all the forces must be 0, and sum of moment of forces about any arbitrary point must be 0. So using these two equations, we solved two unknowns, and which is the reactions at A and B.